Yeah, we should be live. Are we? Don't know. How long does it take? I need to refresh the page or something. Keep saying upcoming. Right. Now it's live. Do I get any sound? Yes, I do. Seems like I'm using the right microphone. So that's great. Don't really want to hear my voice. Just put this away. We have ChatGPT in code interpreter mode. We also have Bing AI and bot, just in case it starts to hallucinate. Oh, forget. Let me quickly post the link to this. I normally post on I said get a shareable link. Oh, wait, how about right from here can share. I'll be sharing on Twitter, which is now called something else. No one cares about Twitter anymore, I think. But I'm posting on it anyway. And also on LinkedIn. Give me a sec. So I was posted. We left off this code yesterday. I did this. We meant to start off a cochlear implant 3D model and ended up with this. So as you can tell, I was trying to correct it in Bing, but it's essentially producing the same code, claiming it's its own. Yeah, I think all this generative stuff will still need to see how it affects copyright. Some of the code before I was trying to search online, I couldn't find anything because I was wondering if GPT that's anyway, so this model is obviously, as you can tell, is not great. I was trying to improve it. It didn't quite do much better. So I might leave it at that for now. But just out of curiosity, if I'm pasting this back to GPT code interpreter, let's see what it says. Let's just paste it in bot as well. It's fine because GPT-4 couldn't even give me the list of current LLMs. And it doesn't even know what an LLM is. It says it's something else rather than large language model. So, yeah. But the code it generates is working. So that's great. I was just wondering, where is it taking those examples? This is the TriMesh NumPy example I was just wondering how reproducible this code is. So if I, because I think it's taking it from one or two repositories. This is not a large language model generation. So here's, no, I copy pasted the code and it's generating something else. I think it's trying to fix some things. Yeah, it's trying to execute stuff on this drive. It has access to, which, yeah, I don't know why it does it by default. You have to tell it not to do it. The sound is, did it actually change the model? No, it doesn't look like the numbers are the same. Yeah, it just generated the same code and executed it on its online on its own server. Now I can download the model, but that's not what I wanted it to do. Did give some explanation to the model. But I'm wondering, um, where is it taking it from in terms of we just do a regular search. Right, so there's this Stack Overflow. Someone says, I solved it. Yay. Transformation, 3D. Rotation of meshes in PyTorch. Why do you need PyTorch for this? Um, that's an interesting one. This one as well. Yes. Yeah, this code looks different, but it must have been taking bits and pieces from it. Um, yeah, it's quite interesting. Just trying to figure out where is it taking this code from, because and how repeatable it is. So when I change something or ask it to generate that sentence from scratch in code interpreter, function interpreter, yeah, try mesh library. Yeah, so if we, it's essentially a prompt that it generated for us. Just pop it back into the bot, see if it gives us something different. It will be like a fourth or fifth. Yeah, I had the original model. Um, that from memory, yeah, it gave us this 2D model, not quite a model. Um, yeah, I was trying to correct it several times, but it just stuck to this kind of thing. Whereas obviously, if you've seen an image of a coconut pie, I can't show any on screen just in case it's copyrighted or something. But yeah, you can just Google it. You know what it looks like. So that meant to be an ear of a human. The coconut plant meant to be in the inner ear, so essentially inside the head. Then you meant to have a behind the ear processor and a coil attached to a magnet. So that's what it came up with, obviously. As you can tell, it's pretty bad. So now we use the same prompt. Let's see if it generated something different. So now we're actually doing a head. That's the object. Let's see if it's actually saving a file head model. Do we? No, we don't have that object. So the name of the file should be safe. Just call it head model copy. Don't know how many copies we had. So I'm getting all mixed up in the files. No, this one is different. So generate another copy. So I was just trying to see which one is better. This code seemed to be complete. Yes, I just run it. Right, and we got. Let's do. Adjust the size of it, hopefully. And it did this. That it gave it some sort of mustache, meant to be a mouth. The eyes are now popping outside the head. That's the mesh. The ears, well, I told it to attach them to the head because before they actually look like hands on the side of the head. It did that, but they obviously they don't look anything like a real ear. Yeah, so that's another model. But the good thing they're being automatically generated, so I didn't actually have to spend much time on making them. And yes, you can, if you ask it nicely, it will put them in different colors and things. That should be easy. But in terms of improving this model, we can give it a go. Try improving the model, make the ears more realistic and the head as well. They're not just spheres. Add more points. Don't use spheres at all. And add colors to the different components. Let's see if it does any better. We don't want to spend too much time on this. It was able before to like generate more details, but then it tends to stuff things up. Let's see what it does different. No, I don't want to check the marketplace. Head, try mesh creation, icosphere. So now it's UV sphere, radius of 1. So it's just another sphere. Like what? Apply scale, scaling it. Probably to like stretch it and stuff. Yeah, I didn't realize before it was doing this translation to 0, 0. So yeah, it's doing something else now. Right eye. Right, it's instead of a sphere, it's using an ellipsoid. That's fine. What do I have a feeling? This code will not execute. A head model. Create another copy. Oops. And run it, it will save the file. Right, yeah, I had a feeling. Yes, I don't know what's up with this. Is it it will probably say, oh, there used to be an ellipsoid, but it's not available now. But then it's able to correct it. Yeah, so it says, apologize for the oversight. As of my last training data is in September 21, right? So they haven't retrained the model since that time. Okay, so it's now back to sphere and then scaling it. to transform into an ellipsoid. But I'm also curious if you pop this code into a Bing, what would it say? Hopefully, it will try to correct it. Good work. uh, any issues with this code? Sometimes, yes. So I find that the Microsoft Bing is very touchy. It's like getting upset a lot. I don't see any issues. Provide me the. Well, how about this one? I'll say, oh, I'm sorry. It's suggested to use a box chef. Why? And still using an ellipsoid. So it's calling it an ellipsoid, but it's actually a box. But it's scaling it with a 1, 2, 3 scale. Interesting. Okay, I don't think, yeah, I think it will keep looking like that. So originally I thought you can just load the image into it. But no, I mean, you can find 3D objects. Sure, there's some open source, like Creative Commons license, something, but I want to create my own um, for all sorts of reasons. Let's see if right. So this one finished. Ellipsoid scaling them into spheres by scaling spheres. Let's see if it executes at all. We only need code that executes. So it added colors. Oh, why it's so big? Made the ears ginormous or something. Right. Uh, the mouth. Yeah, it's this disc shape. You can see it from the inside of the mesh. Yeah, it's really this. Obviously, doesn't look like anything at all, and those meant to be ears. So obviously, they out of proportion. Should we keep? I don't know why it's scaled the head this way into like a watermelon shape instead of scaling it vertically. Yeah, I don't see how we can improve it by much, but it's better than nothing. Yeah, I don't know if I should continue this or not. Probably not. Um, let's see what else we've got. Head model. That's the particles thing. Hopefully, you had a chance to play with it. Someone actually asked, "What is the model?" And I don't know. I think it's pretty random. So it's this thing on the site. The site is up and running. I'll just show you the development server, so the ads are not there. So the good thing about example is that it should be all available in terms of all the source code. So it's a good example of where all the source code is available. It's this particle motion, it has this HTML. The Python script is not actually being used, it's being translated into JavaScript. Can we start a new chat code interpreter? Pop this code in. Yeah, I'll just run it first, see what it says. Sometimes it might say something interesting. Most of the time, not. Sometimes it's starting to fix the code, even though I didn't ask it to do so. Yeah, this is the description of it. Just read it aloud for a sec. I'll be back in 20 seconds or so.
This is a simple particle simulation where particles are confined to move within a square box, canvas. Particles move and bounce off the walls of the box. Particles can also collide with each other and bounce off one another. Here's a breakdown of the main parts of the code. Initialization. The canvas is fetched and its size is set based on the width of the container. The number of particles, their radius, and speed are set. An array for positions and velocities of the particles is created. Initialize particles function. This function initializes the positions of the particles randomly within the canvas, making sure they are not too close to the boundaries. The velocities of the particles are set randomly based on the speed. Update particles function. This function updates the position and velocities of the particles. Boundary collisions are detected, and the velocity is reversed if a particle hits the boundary. Particle-particle collisions are detected and velocities are updated accordingly. A rotation matrix is applied to simplify the calculation of the collision in 1D, and then it's converted back to 2D. Draw particles function. Clears the canvas and then draws each particle at its current position. Main loop function. This is the main animation loop. It calls update particles to update positions and velocities and then calls draw particles to render the particles on the canvas. The request animation frame method is used to call the main loop function again, creating an animation. Restart simulation and update number particles functions. Restart simulation resets the simulation. Update number particles updates the number of particles based on user input and reinitializes the simulation. Event listener for window resize. Whenever the window is resized, the size of the canvas is updated and the particles are reinitialized. Finally, the particles are initialized and the animation loop starts with the call to main loop. This is a neat simulation that showcases the basics of particle physics in a confined space with simple elastic collisions.
Right, so this is elastic collisions. Why didn't it say it in the beginning? Do want to quickly change the title, particle motion simulation. Yes, this is a better description than what we currently have. How long a description can be? I might actually use this one actually on the page. No, actually, I like it that way. I don't want any label there. Just have it at the bottom. And that explanation was much better. Can you convert the last response into HTML text? Obviously, don't need that. Just need the simulation breakdown. So yes, this is a full disclaimer. I do use ChatGPT to generate not only text on my website, but the tools themselves were generated by ChatGPT. So, so there's no questions uh, regards that. Still generating, like the biased language there. It's a neat simulation. Well, it wrote it, so obviously it thinks it's neat. But I do want to replace all that. Let's see. Main loop function. Not quite the text. The font is like that, but it should be okay. Right, so we had that one. Close this object. I have this speech rate and still haven't got much feedback on it. Let's just test it quickly, see if it still works. Does seem to work. Should give you the speech rate. Has all the yeah, this is pretty good description. Speech detected. What else did we? There's no errors, at least not yet. It's actually some of the errors are coming from the JavaScript code, so actually should be there, like when the tab browser times out and things like that. Um, right, so we covered this, covered that, video editing, removing silence. So that just wasn't published yet, but I do use Python script to essentially help me editing the YouTube videos. And it's basically splits a long video recording, chops it out into smaller bits, um, and cuts out all the silence. So when I get stuck or daydream, it will cut it out. Um, It's not real. There's no learning in it or anything. It's pretty basic. Just automated automation. It will just look at where do I have this code? Not sure. And there's no really user interface to it. Well, not yet. I can find the code, but I might just just leave it as a middle priority kind of thing. We'll get back to it later. Right, and this will be a top one of the top priorities. Is that finger recognition, which we haven't touched in a while. So I might get back to it now. And I don't remember, did I have it on the website? Probably not. Web. This JavaScript. This JavaScript is in a folder called webcam. Right. Open the flasher. And this doesn't work. Is it giving an error? It's having trouble loading the media pipe. Right, I remember that vaguely. We can try and fix this. It's the description. Alright, so we had this Python code. This one is giving an error as well. Source is empty. I think that's because I'm using the camera. Work with the second source. Right, it does. So that's what we wanted. Yeah, so I had lots of videos on this. We also have it there in the background on my screen. My first camera is like flickering in a weird way, which would not be surprising. Quality of this thing. Higher picture quality. Yeah, to get that quite a bit. It is flickering. Might just Q is closing this window. Does it stop? Yeah, it does stop. Right, so that's the two. It's the USB ports like interfering. They wanna know. What the quality of the images? Um, quite poor. Yeah. No idea why that is happening. I just move on. Let's check this code again. Right, so we have it on my, yeah, this camera starts playing up. So this guy on my, whichever way, whichever direction it is. So it's working fine. And we were trying to turn this into a JavaScript, a HTML tool, but it didn't quite work. So what we can do with ChatGPT, still transcribing. Yeah, it's transcribing some rubbish. As in, yeah, I could say what I'm saying is rubbish, but it's also not transcribing well. So I never said anything like that. But that's probably as good as it gets. Let's start a new chat. What we want to do is have this code. So ChatGPT code interpreter, that's okay. So we know this code is actually working. Well, because I'm running it at the moment and it does what I wanted to do, which is great. It's giving this description. Wanted to summarize essentially. Can you ask it to create a prompt? Can you create a prompt that will generate this code? So, like reverse engineering, prompt engineering. Right, so that's nice. Well, that's essentially what this is it? This is a long prompt. There's something in the chat. No. A Python script. Right, so we want this in JavaScript. And it's okay to use TensorFlow JS. But ensure the code is written cleanly and well documented. Right, so I don't need to share source code, do I? Just share this prompt. The thing, though, is I want to turn it into a create Python script. So detect and visualize phase and handlines my from video stream. Uh, so create script. I don't want to. It doesn't necessarily have to be Python. It doesn't necessarily have to use those to detect and visualize face and hand landmarks from a video stream. So I wanted to do it from a webcam in a browser. And again, don't want any names in it, so I just choose stuff from scratch. So the video capture using browser. Yes, from a webcam. Convert it to. Do we need to convert it? Um, it's just face and hand tracking models. Do you know about RGB? I don't care. If any face model are detected, visualize them on the frame. Right, no, that's okay. You can. That's just commented out code in here. Well, yeah, put them in different colors. Label each hand landmark with its index. Don't have to do that. Can get rid of it. In a browser window. I don't care about this at this stage because you can just close the tab or close the browser. So I want this thing on my side in a browser. I don't know why my first camera is playing up. So obviously those are separate cameras as well. Might just, yeah, if I close it, my camera stops playing up. Yeah, it stops playing up. Let's see. So it's HTML code, which is great. Turning on webcam. Right, so using TensorFlow.js. Okay, so I didn't prompt for it, it shows it itself. But this is great, this is what we want. Hopefully these models are correct because sometimes it brings out stuff that doesn't actually exist, but we will know that in a second. And this is the script, so this really should be moved into a JavaScript file. Right.
Save the above code to an .html file. Open the file in a web browser. Grant permissions to access the webcam when prompted. You should see the video feed with face and hand landmarks visualized. Remember to always serve the script over HTTPS to ensure the browser allows webcam access.
Yeah, for sure. So this should be, well, the first one wasn't, this thing wasn't working to begin with. We might just keep a copy of it, but we'll work with the current index file. Oops, didn't copy. Can, oh no, close, wrong button. Open with lifesaver, allow. Right, is it having trouble? With the second camera. Right, so this is working in the browser, but I don't get any. Let's see, getting an error, type error. What? Media pipe face mesh. Okay. So only try fixing once or twice. Oh, yeah, and my first camera is going. Obviously, the two USB ports are interfering with one another. Let me just plug it into. So this one's still using my camera. It's probably timed out. Are there any errors? No, it's still going. That's surprising. This one's going with my camera, but it has an error. Let me just quickly. So first one is working okay. Probably will need to be refreshed. Having trouble with the video source. It's always reverting to the first one. Right, now it's working better. Yeah, and my first camera is not flickering, so that's great. Can close that. Transcription is still going. Or not. Hmm. It's using my same microphone directly. Well, that's obviously stopped working. I'm just looking if that meant to pop out the recording ended restarting. That error is okay. Let's do the ads advertisement on the website. Yeah, but that's obviously not restarting. So I have to fix that. I'll just close it for now. We'll look into. Right. I'll be.
The error you've encountered
back in a
indicates that the medium height face mesh
sec.
property cannot be found on the face landmarks detection object. This could be due to several reasons, including changes in the library or its API after my last update. To address this issue, let's use an alternative approach with a different model. We can use the BlazeFace model, which is also part of the TensorFlow.js suite and is designed for fast face detection. Here's the modified script. HTML. Copy code. Doctype HTML lang equals n head meta set equals UTF-8 meta name equals viewport content equals width equals device width initial scale equals 1.0 title of face and hand landmarks detection slash title slash head body of video ID equals webcam width equals 640 height equals 480 autoplay slash video canvas ID equals canvas width equals 640 height equals 480 slash canvas load TensorFlow.js library script src equals https://cdn.deliver.net slash npm slash at TensorFlow slash tfjs slash script load face and.
The question is it a full script? Does it have any missing bits?
Script. We replace the face landmarks detection model with the BlazeFace model. Try running this script and see if it works without errors.
Yeah. Hopefully it just didn't just hallucinate stuff. Yeah. Leave that one running. I mean, it is doing something useful. Just keep a copy of it. Oh, come on. This one doesn't have any errors. Oh. It's doing that. It's like grabbing print screens for unknown reason. Giving this long error. It's time to do that blaze face. Blaze face. Blaze face. Interesting that it's doing it like after sometimes just grabbing a print, like a image, a stills image. And what's What's that all about? Pixel-based browser must be ever. TensorFlow.js.
The error you're seeing is due to the input type passed to a TensorFlow.js method which expects a certain type of element or data. The issue is likely with the way we're passing the video element to the model's estimation method. Let's modify the detection part to pass a TF, tensor derived from the video element's pixels, rather than passing the video element itself. Here's how you can modify the detect and draw function. Detection part to pass a TF, tensor derived from the video element's pixels.
Okay, now we need to break it. So it broke it down to HTML and JavaScript. Was this file, this HTML was calling JavaScript? No, because it had the JavaScript inbuilt. Now it's saying changing detect and draw function. Might as well pop it into separate. Detect and draw. Yeah, it did quite a lot of changes. Can you update the changes and generate both HTML and JavaScript codes on the screen? Yeah, because sometimes it's trying to generate them as files or even run them on its own server. It's just like, do not. I need to run it locally. So it's the HTML, just the point should be a short one. Should be calling the JavaScript. I don't see the JavaScript call. Yeah, no, I do see it. Okay. I will clean it up later. We'll just keep going with the versions. It's our own version control. I mean, yeah. People were going nuts about version control, but I just like having stuff that's actually executable and running, and then there's no problem. So then version control is not a huge thing. Landmarks JS. Pop this in it. So I have this webcam canvas in 2D as a face mode. Has not too many comments. I'll have to generate more comments.
You can save the HTML code in a file named index.html and the JavaScript code in a file named landmarks.js. When you open the index.html file in a browser, it should work as intended. Regenerate. ChatGPT may produce inaccurate information about people, places. HTML code in a file named index.html and the JavaScript code in a file named landmarks.js. When you open the index.html file in a browser, it should work.
Yeah, this is it. So seems like every now and then it's grabbing an image, then not actually doing anything with it. Did it place the labels? In the original prompt, what do we have? No, it's okay. Process the frames using a face mode detected. Uh, so I don't see any faceless marks on the frame. I have a feeling we'll be getting stuck in a minute. We'll just keep going for now. Don't know what it's trying to do. There's this warning, but I don't think it's related. It's just the sake of just check it in our browser. No, the camera is obviously used in there. What is it? These two browsers should be the same as in Chrome because it's Chromium based. It should be okay. Yeah, let's troubleshoot.
Apologize for the oversight. Let's troubleshoot the issue step by step. Ensure the blazeface model provides the expected output. The blazeface model is primarily for face detection and returns bounding boxes. The landmarks it provides are primarily the key facial features: eyes, nose, mouth. If you're expecting detailed mesh-like landmarks across the face, the blazeface model will not provide that. For a detailed mesh, we need a different model, like the media pipe face mesh model, which we initially tried to use. Debugging. If the bounding boxes and basic landmarks aren't visible either, there might be an issue with our drawing logic or with the model prediction. To check if the model is making predictions, add a console.log face predictions after the line const face predictions equals await face model.estimate faces TFIMG in the detect and draw function. This will allow us to see if the model is detecting faces and returning predictions. Drawing issue. If the console.log shows valid predictions, but you're still not seeing landmarks, there might be an issue with our drawing logic.
So this is obviously in the JavaScript. After this, ba, 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 ba. There's no such line. So in the detect draw function, const face prediction is there. After the line const prediction, console log face predictions. That's pretty straightforward. Pop it in there. This empty, is it? Pretty sure it's empty. The predictions are empty.
The console output indicates that the blazeface model is indeed detecting a face and providing landmarks for it. Specifically, the model provides landmarks for 6 key facial features: the eyes, the nose, and the corners of the mouth. Since the predictions are being made correctly, the issue likely lies with
What? Where are the actual numbers? Ah, there are numbers. Right.
lies with how we're visualizing the landmarks on the canvas. Let's ensure our drawing logic is correct. From the output, we can see that the model provides top left and bottom right coordinates for the bounding box and an array landmarks for the facial features. From the output, we can see that the model provides top left and bottom right coordinates for the bounding box and an array landmarks for the facial features. Here's an updated and more explicit drawing logic.
For that line. Right. But this for function. Oh, is it working? Okay, I don't get it. I don't know what it does. There meant to be I have a box over my face. I don't see it.
Ensure that this drawing logic is present in the detect and draw function. If you've made these changes and are still not seeing the landmarks, try increasing the size of that this drawing logic is present in the detect and draw function. If you've made these changes,
Yeah, detect and drive. Yep.
changes and are still not seeing the landmarks, try increasing the size of the circle being drawn. Example, change the 2 in canvas ctx.arc x, y, 2, 0, 2 asterisk math.pi to a larger value like 5. This will make the landmarks more visible on the video feed.
A canvas. Have it arc blue. Begin path is still blue. Two. 5. And no. 5. No. Meant to be. Don't see a circle at all. Seeing landmarks increase the size of ceremony. Still not seeing landmarks. The landmarks supposedly are there. And just show me the landmarks on screen. I'd like to see them over here, indicating where the face is detected.
First, ensure the canvas is not overlaid on the video element. We can do this by using some basic CSS.
Do we have CSS in here already? Oh, yeah, it's good when you will need a CSS file anyway. Style, there's no style. Can we put this as styles? Yes. Pop this in there. I don't think we need this or that. We'll save and index should be calling. It actually should be calling both of these files. There are landmarks. Oh, pa, 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 pa. Okay, get rid of this one for now. the second thing. The drawing logic, so this will be in the JavaScript file. Key points. Don't I need any of this? No errors. No drawing.
This change replaces the small dots with slightly bigger squares and uses a bright lime color for better visibility. If, after these changes, you still can't see the landmarks, please check the following. Browser console, open the developer tools in your browser, usually F12 or right-click and inspect, and check the console for any errors. Camera position, ensure the face is clearly visible in the camera feed and is not too close or too far. Visibility, sometimes, the landmarks might be small or blend into the background. The line color and square size adjustments are intended to help with this. Library versions, ensure that the browser is loading the latest versions of the TensorFlow.js.
Wait, first of all, I did get an error. No, that's fine. That's not the important. Just the icon. Ba, 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 ba. I don't know what's up. What's up? Too close or something. So you can say. Yeah, you can say it's not detecting it and yes, detecting it. Yeah, because you see when the face is not in the footage, there's an empty array, which is awesome.
Sometimes, the landmarks might be small or blend into the background. The line color and square size adjustments are intended to help with this. Library versions, ensure that the browser is loading the latest versions of the TensorFlow.js libraries. Sometimes, older cached versions can cause issues.
So it's obviously working, but there's no bloody square. No square. Where's my square? Oh, come on. It's doing something useful. So we might keep going with this for a while.
The visibility issue might be the primary reason then. Let's take some actions to enhance the visibility. Increase landmark size. If the landmarks are too small to be noticed, increase their size. Change color for better contrast. Use a color that contrasts well with skin tones and most backgrounds. Let's implement these. Increase the size of the landmarks. Instead of using small dots or squares, let's use larger squares to represent landmarks. This should make them more noticeable on the video frame.
Wait, are we? Why are we doing this multiple times? Draw landmarks. Draw face landmarks. Oh, come on. It does not work. But seriously, why do we have this twice? Can you regenerate the JavaScript script? And also, why Canva CTX is being set twice? So it's this. Oh, multiple times. It's obviously doing something useful again because when the face is not there, it's not detecting it. Those coordinates must be correct. I want to display them on screen somewhere. I forgot to mention it. Yes, it's removing the fill style. It's still generating the code. One page.
In the script above, we have consolidated the fill style and stroke style setting at the beginning of the detect and draw function so they're not being set multiple times. Simplified the drawing logic for the landmarks to enhance visibility. Added a border around the face landmarks for better contrast. Now, using this updated landmarks.js script with the previously provided HTML should display the landmarks more prominently. Regenerate. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT August 3rd version.
Just see something on the screen. No, the error is not relevant. Remove that previous line that was actually monitoring the. No, that was there. Um, can you change the code and display landmarks as numbers, coordinates on the video footage? So still don't see it. There might be some sort of square around my face. What's that? It's a producing queue. It's weird.
Code interpreter. Landmarks as numbers or coordinates can be achieved using the fill text method of the canvas context. I'll modify the script to display each landmark as its index number, for simplicity, for both the face and hand detections. If you prefer the actual coordinates, that can be done as well. Script to display each landmark as its index number, for simplicity, for both the face and hand detections. If you prefer the actual coordinates, that can be done as well. Here's the modified landmarks. With this modification, each landmark on the video footage will be displayed as a number, representing its index in the landmarks array. If you want to display the coordinates instead, replace the J in canvas.ctx.filltext, J, X, Y, with a string representation of the coordinates, like canvas.ctx.filltext, $x, $y, X, Y. Regenerate. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT August 3rd version.
Oh, come on. Getting stuck. It was working better before. Let's start a new chat. Is this one starting to hallucinate? A contributor, yes. And we had I don't know which copy. So what's this queue in the console doing? Right, this is the one that seems to work. I'll pop it into another chat. Maybe it picks up on some mistakes already.
Code interpreter. Provided code sets up a real-time webcam feed and uses TensorFlow.js to detect and draw face and hand landmarks on a canvas. Here's a breakdown of the code. Initialization. Video element represents the webcam feed. This code provides a real-time application for face and hand detection using TensorFlow.js. Users can see the landmarks of their face and hands drawn on a canvas overlaying their webcam feed.
And no face and landmarks drawn on canvas. Like, yeah. There's no errors. I don't know what that queue is all about. Get a queue. I think it's actually working.
Ensure that the canvas element is of the same size as model loading. Check if the models, blaze face and hand pose, are being loaded correctly. The URLs or paths to these models might be incorrect, or there could be network issues preventing them from loading. Webcam permissions. Ensure that the website has been granted permission to access the webcam. A blocked or denied permission will prevent the webcam feed from appearing. Library imports. Ensure that all necessary libraries, especially TensorFlow.js and any required models, BlazeFace, HandPose, are correctly imported and available. Video playback. Ensure that the video from the webcam is playing. Sometimes, the video might not autoplay due to browser restrictions. You can try manually playing the video using videoelement.play in the console. Drawing logic. Check the logic inside the detect and draw function. Ensure that the draw ChatGPT
So I copy the whole thing. Copy object.
provided JSON structure appears to represent the detection of a face from a model, possibly like the BlazeFace model mentioned in the earlier JavaScript code. Here's a breakdown of the data. Is an array of coordinates representing specific facial landmarks. The order and meaning of these landmarks would depend on the model specification. This indicates the confidence score of the detection. A value close to 1.0 suggests high confidence in the detection, while a value you'd like to draw this on a canvas. Here's a simplified example based on the structure.
Is this specific to my code? Draw bounding box. Detect and draw. Ba, 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 ba. Yeah, it feels like we
Check the logic inside the detect and draw function. Ensure that the draw image, fill rect, and other drawing functions are being called with the correct parameters.
detect and draw this function. Find page. That should be fine. Can check. The coordinates seem to be working. So check the logic inside the detect and draw. It's not drawing the square on the screen, which is annoying. So we have this canvas, draw image. Should be the same line. I don't expect this to change.
This line draws the current frame from the video element onto the canvas. The parameters look correct. It starts drawing at the top left corner, 0, 0, of the canvas and scales the video to fit the canvas's width and height. Converting to tensor. This converts the image from the canvas into a tensor format for TensorFlow.js to process. This seems fine. Face detection and drawing, for each detected face. This part of the code gets the x, y coordinates of each face landmark and draws a 6 by 6 square centered on that point. The parameters seem correct. The subtraction of 3 from x and y centers the square on the landmark.
Okay. So if this is correct, why do you mention this? This box is like too small or something.
For each detected hand. JavaScript. This code gets the x, y coordinates of each hand landmark, starts a new drawing path, and then draws a circle centered on the landmark with a radius of 2. It then fills the circle with the determined color, yellow for right hand, red for left hand. This logic seems correct, and the parameters look appropriate.
There's no boxes. This landmark should give us the coordinates. Can this number just be updated on the screen?
This line disposes of the tensor to free up memory. It's essential for smooth performance and preventing memory leaks.
This potentially the problem.
This line ensures that the function is called continuously, allowing real-time detection and drawing. From the code review, the logic inside the detect and draw function seems correct, and the parameters for drawing methods appear to be appropriately set. If the landmarks are still not showing on the canvas, it might be worth considering other parts of the code or ensuring that the detection models are indeed identifying faces and hands. If the models don't detect any landmarks, the drawing routines won't be executed.
They are identifying. I think. This would be the copy object. Something with the box. Something simple I don't get. So what's that Q in the output? But it's working okay because yeah, when there's no face, it's not detecting any coordinates, which is what it meant to do.
Given the data you provided, it seems that the detection model is indeed identifying a face. This data appears to represent a single face with its bounding box, top left and bottom right, and landmarks. Here are the relevant parts of the detect and draw function based on this data.
Yeah, detect and draw. Okay.
Given the sample data, the first landmark is at, which means a magenta square should be drawn from 2. Similarly, the other landmarks would have their respective squares. Given this logic and your data, the landmarks should indeed be drawn on the canvas. If the landmarks are not being drawn, let's troubleshoot further. Visibility. Ensure that the canvas is not hidden or covered by other elements. If the canvas is stacked below the video element, you might not see the drawn landmarks. Canvas clearing. If there's any logic elsewhere in the code that clears the canvas, it could be erasing the landmarks before they're visible. Look for any calls to canvas.ctx.clearrect or other methods that might clear or overwrite the canvas content. Drawing color. The landmarks are drawn in magenta. Ensure there's no other logic changing the fill style of the canvas CTX between drawing calls.
And let's check this one quickly. It does being called twice. Is this overriding? We already have a console log somewhere. Console log Face predictions. Get that one away. It should be happening later. Like here. Still not defined. The end. I'll just keep the previous stuff. I don't think that what the problem is. Could be no, there's no calls to clear.
Context state. Ensure there are no transformations or state changes applied to the canvas context, canvas CTX, that might affect drawing. Drawing order. Ensure that the face landmarks are drawn after the webcam feed. If the feed is drawn after the landmarks, it would overwrite them. If after checking these points the landmarks are still not visible, there might be issues outside the provided.
Can you check them for me? Can you check these issues for me? You have the code. Yeah, I might be moving on shortly. It's annoying because I know it's doing something useful. The coordinates are there. There's no face, there's no more coordinates.
The code doesn't have any CSS or positioning logic, so we can't determine the layering of the canvas and video elements. However, you should ensure that the canvas is positioned above the video element or at least has a.
Wait. First we do have style CSS. Ensure that the canvas is positioned above. Okay. So that's the CSS.
There isn't any call to canvas ctx.clearRect in the provided code. Provided CSS positions both the canvas and the video element, webcam, at the top left corner of their parent container. Since they both have position, absolute, they will overlap each other. Given the z-index values, the canvas, with z-index 1, winky face, is positioned above the video element, webcam with z-index 0, winky face. This is the desired configuration since you want the drawings on the canvas to appear on top of the video feed. This CSS seems correct for the purpose of overlaying the canvas on top of the video feed. Here are a few things to ensure. Canvas.
Okay.
The fill style of the canvas CTX is set to magenta for face landmarks and either yellow or red for hand landmarks. No other colors are set in the provided code, so the colors should be correct. Console logging. The provided code already has a console.log, face predictions, which logs the detected face landmarks. You should see this output in your console, and if the face landmarks are detected, the drawing logic should be executed. If you're seeing this console output but no drawings, it's an indication that the drawing logic might be the issue. Context state. There's no transformation or state change applied to the canvas CTX in the provided code. The only operations are draw image, fill rect, and drawing circles with begin path, arc, and fill. So, the context state seems fine. Drawing order. The webcam feed is drawn onto the canvas before the landmarks, which is the correct order. This ensures that the landmarks are drawn on top of the video feed and not overwritten by it. Given the analysis of the provided code, the drawing logic and order seem correct. The colors and context states are set appropriately. If the landmarks are still not being drawn, you might want to check the positioning and layering of the canvas and video element in your CSS. Ensure that there's no other JavaScript or logic that might be interfering with the canvas drawing outside of the provided code. Check the positioning and layering of the canvas and video element in your CSS. Ensure that there's no other JavaScript or logic that might be interfering with the canvas drawing outside of the provided code.
No. Okay, wait. uh, that's script. It's using media pipe that wasn't working. We can rename it just in case it's interfering with something. So we have this index landmark and CSS. So the CSS, I think it says it's okay.
The provided CSS positions both the canvas and the video element, webcam, at the top left corner of their parent container. Since they both have position, absolute, they will overlap each other. Given the z-index values, the canvas, with z-index 1, winky face, is positioned above the video element, webcam with z-index 0, winky face. This is the desired configuration since you want the drawings on the canvas to appear on top of the video feed. This CSS seems correct for the purpose of overlaying the canvas on top of the video feed. Here are a few things to ensure. Canvas transparency.
Let's just try this thing in a different browser. No, nothing. This should be boxes. Just happen. A console. Is that array 1? Should. Right, that's when the face wasn't on the screen. Let's close it here for a sec. Try it in another browser. It doesn't work at all. It does work in Chrome. No errors. Yeah, same thing. Does. Has trouble loading. Let's give an error. Let's show it in here. Huh. Wait. No, it was different one. Yeah, this one. But then it seemed to recover from it. And you still have anyway. Something basic that I don't get.
Transparency. By default, the canvas has a transparent background. Ensure that there's no other CSS or JavaScript code that's setting the background of the canvas to a solid color, which would obscure the video feed underneath. Canvas and video size. Ensure that the canvas and video element are of the same size. If they are different sizes, the landmarks might be drawn outside the visible area of the canvas. You should set their width and height either through CSS or JavaScript to ensure they match. Other CSS. Ensure that there's no other CSS that might be affecting the visibility or positioning of the canvas and video element. Other JavaScript. Double check that there's no other JavaScript interacting with the canvas, which might affect its content.
Well, let's just check that we have only the one JavaScript running. Yes.
Given the provided CSS and the earlier JavaScript, the landmark should be drawn on the canvas, and the canvas should be overlaying the video feed. If you're still having issues, it might be beneficial to create a minimal version of your project to isolate the issue or to check if other parts of your code might be causing the problem. DevTools failed to load source map, could not load content for https://cdn.jsdlibr.net/npm/tensorflow/tf.min.js.map, ht. The warning, DevTools failed to load source map, is a common message you might see in the developer console. It's important to note that this is a warning, not an error, and it often doesn't impact the functionality of your website or application. Here's a breakdown of what's happening. What is a source map? A source map is a file that maps from the transformed source, often minified or transpiled code, back to the original source. This allows you to view and debug the original source code in your browser's developer tools, even if you're actually running a modified version of the code, like a minified file. Why the warning? The warning is telling you that the browser's developer tools tried to load the source map for it tensorflow/tf.min.js but couldn't find it. This is likely because tensorflow.js, when served from that CDN, references a source map that doesn't exist on the CDN. This is common with libraries served from CDNs. Does it affect functionality? No. The absence of a source map doesn't impact the functionality of tensorflow.js or any other library. It only affects the ability to debug the original, non-minified, source code in the developer tools. How to address it? Given the provided CSS and the earlier JavaScript, the landmark should be drawn on the canvas, and the canvas should be overlaying the video feed. If you're still having issues, it might be beneficial to create a minimal version of your project to isolate the issue or to check if other parts of your code might be causing the problem.
Yes, we're still having the issue.
Yes, based on the provided JavaScript and CSS, everything seems to be set up correctly for the landmarks to be drawn on the canvas, and for the canvas to overlay the video feed. If the landmarks still aren't being drawn, here are steps to create a minimal version of your project to help isolate the issue. Simplify the HTML, start with only the essential elements.
Yeah, we want only essential elements. Animals. Yeah, the CSS is stripped down. The webcam feed and the canvas are the same size. Yeah, that's interesting. The CSS. My thing. CSS. It's the same. Let's do some. Maybe not the same size anymore. It's if I put the canvas first. It's just weird. That should be fine as before. Simplify the JavaScript.
For now, focus only on face detection to reduce the complexity. Once that works, you can add back the hand detection.
Okay, that's. Do I have no? A hand model. Move the hand model. Can I do this? Still the hand model being commented out.
Test in a clean environment. Run the minimal version in a new, clean HTML file. This will ensure no other scripts or styles interfere with the process.
Does it? Does it matter? I close there. No, that does not matter.
Add more console.log statements to ensure every step is being executed, especially inside loops or conditionals. For instance,
X be over here. Right. Log. We can call this out. So len. So they are being drawn.
Running your minimal version in different browsers to see if it's a browser-specific issue. External libraries. Ensure
Let's try Firefox. Yeah, I get the same thing. It's finding the face. There should be a probability as well and things like that, but it's working fine even if the face is blurred. But there is no there is no box. That index. Let be X. Right, the numbers change as they should.
Ensure that you're importing the required libraries correctly, especially TensorFlow.js. Double-check the versions and the URLs if they're being loaded from a CDN. By stripping down to a minimal version, you'll either find that everything works, indicating the problem was elsewhere in your original project, or that the problem persists, which would narrow down the potential causes. If the latter happens, you can share the minimal version with others for feedback, or continue to adjust and test until you find the root cause. Stripping down to a minimal version, you'll either find that everything works, indicating the problem was elsewhere in your original project, or that the problem persists, which would narrow down the potential causes. If the latter happens, you can share the minimal version with others for feedback, or continue to adjust and test until you find the root.
Yeah, if anyone knows what's going on, any feedback will be greatly appreciated. Can you test the box drawing by drawing a box at the fixed location over the webcam video footage?
After drawing the webcam video footage on the canvas, but before drawing the landmarks, add the following code to draw the box.
Detect and draw. Pop some constants in there. Drawing the webcam. So about here. Right. I did a mistake. Get rid of that. Canvas draw the fixed box. This goes in here. So there is a fixed box. That's working okay. So there, focus. That's box is drawn.
Adding this code, every frame from the webcam footage will have a blue box drawn at the specified location. If you can see this box, it indicates that the canvas overlay is functioning correctly and that drawing operations are being applied as expected.
No. Why do I suspect? So the box is at 50-50. Box should be much larger. Where It's something to do with the size of this screen. No, that there is fine. So like outside the boundary of this thing. Can you place a dot at X, Y location? X, Y. Of where the face is being detected. Yeah, the box. Detect and draw. Format document. No, this is an error. Don't need that. Leave that there for now. Yeah, that doesn't work. Let's leave it for now. close all that, I think. Image prediction. Right, I might just close all this for a sec. No, not this info. Yes, that info. So we done with this. We have quickly look at the ECG to close the development port for a sec and turn it on again. Right. So we had that ECG waveform simulation and analysis. So normally this description does look legit, but we probably can improve on it.
Design ECG waveform function. Create a function to simulate the basic PQRST pattern of an ECG waveform using mathematical functions. Refine the ECG waveform. Update the waveform function to make it more representative of a real-life ECG waveform. Measure and quantify ECG components. Determine the amplitude of the P wave, QRS complex, and T wave. Initially, set error margins for these measurements. Later, generate multiple QRS complex variations and calculate a precise error margin based on these variations. Store ECG data. Save the ECG waveform data in a separate JavaScript file, ecg_data.js. Store the variations of the QRS complex in a JSON file, qrs_data.json.
I'll just get back to this another time. So I'll see you next time.